All right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into this. This is adding and subtracting radical expressions. So, for number one, all you have to do is pretend like the numbers that are in the square roots are like x, right? So, if you know how to put together like terms, then you'll do just fine on this, right? That's kind of like the prerequisite thing. So if you have any trouble with like terms, I would go back and practice with like terms with x's and stuff first. It's a little bit easier. It's about the same thing actually though. So like terms, definitely helpful to know how to do. Basically, I can put these numbers together because they both have an x. There's kind of like two things that have to happen. They have to have the same letter, x, and the same power of that letter. Because that's important too. If it was like 3x minus 4x squared, those are not like terms. The x's are to two different powers. Here, they're the same letter, right? So like terms, back when we did like terms, you would have the same letter. You have to have the same letter, and the same power, and the same power. And you can put an S on each of those at the end. Letters, powers, there could be more than one. It could be like xy and xy. Those are like terms. Or xy squared, right? Same exact thing. Well, with radicals, so radical like terms, we want to do basically the same thing. You need the same number. So they're both sixes. And you need the same root. Not all roots are the same root. There's square roots, but then there's also cube roots. Let's see if they have cube roots in here. Ooh, they don't. They're all square roots. So we don't have to worry about that for this worksheet, but for harder worksheets, they might do a little 3. Let me show you what I mean. Let's say I put a little 3 right in that little tiny cusp of the Nike check there. That would be what's called a cube root, and then I would have a different root, and they wouldn't be like terms anymore. So let's go ahead and finish this problem out here. 3 minus 4 is -1. And then if it's -1, you don't really need the 1. You can just put the negative sign on there. And then remember, it's root 6, square root of 6. But sometimes we just say root 6. And that's it. That's the answer. Let me show you how easy this can be. All right. So check if they're like terms. Same number? Yeah, 7. Same root? Yeah, square roots. And remember, this is good to go on all of these questions. So I'm really just going to be looking for the same number moving forward because I know all of them have the same root. But if you're doing a worksheet and you know there's going to be cube roots on it somewhere, then go through and make sure you're checking the root too, of course. So same number? Yeah, they're both square roots of 7. So they're the like terms. -3 plus 4 is 1. Boom, that's the answer. And that's really all there is to it. -11, -11, they're both root 21. -11, -11, I'd be adding them up. And that's it, right? Same thing here, -9 plus 10, that's 1. If it's 1, I don't need to write a 1 in front, right? And that's pretty much all there is to it. I mean, really though, that's really all there is to it, and it's not going to get too terrible. It's going to get more stuff, bigger numbers, but that's it. The only thing that I mentioned that they're not going to go over in this worksheet is if there's different roots. So -10 plus 12, that's 2. -3 minus 4 is -7. -10 minus 11 is -21. And notice I just carry over the root. There's not 2 of the roots. It would be like if I say, I have 5 oranges and now I have 4 more oranges. Well, I have 9 oranges. I don't have 9 oranges squared, right? I'm just adding up all my oranges. They're still just one thing here to show how many of them I'm adding up. I'm adding up 10 and 11 basically. So I have 21 square roots of 11 altogether. Negative 21 square roots of 11. So that's all that's going on there. Negative 2 plus 3, that's 1. So, oh, wait, hold on. This one's different. The roots are different now. So these are not like terms. But now there's a precursor step. Now we need to see if we can simplify the radical because we can. And that comes back to a previous video, so I'll put a link in the description and at the end of the video as well. It might be easier to go to the end of the video. Sometimes I don't have all the links that I mention if I forget. But at the end of the video, you can scrub ahead and you can see the playlist for all of these things. And it'll have simplifying radicals in there. My favorite way to simplify radicals is to just see if I can divide by square numbers. So like 4, 9, and 25. Those are all numbers that are pretty easy to find out if they divide by. 27 doesn't divide by 4. It's odd. It does divide by 9 3 times. I know it goes into 9 because 2 plus 7 is 9. That's it. If the digits add up to 9, it goes into 9. If the digits add up to 18, it goes into 9. If the digits add up to 27, it goes into 9. Normally, you don't have to worry about it. Normally, the digits will add up to 9 for smaller numbers. So that's really most of the time all you have to really worry about. But any multiple of 9, if the digits add up to any multiple of 9, the number goes into 9. I don't know why it works. It just does. A little trick there. So then that would be the root 9 times root 3. And again, I'm not going to get into too much detail on how to simplify radicals. That's in another video. But basically, that's what we do, right? It would be 9 times 3 is 27. So it's just the same exact number, just with 2 separate roots. And the square root of 9 is 3. And now they're like terms. They both have the square root of 3. Negative 2 plus 3 is 1. So square root of 3 is the answer. All right, we'll box the other ones too. All right, let's switch colors. Move on to green. So same thing, right? We got to see if we can. If we can't, then we can't, but we got to try. It's even. If I take half, I get 12. 12 is even too. So if I take half, I get 6. 24 is 4 times 6. Root. Square root of 4 is 2. 2 root 6. Now, there was also a 2 out in front already. This 2 right here was already out in front. This is a little different. Whenever you bring a number out front, it gets multiplied by whatever's already out there. Not added, not subtracted, multiplied. So we got to factor that in as well. 2 times 2 is 4. So let me create some more space here. This would be 2 root 6 minus 4 root 6. And now they're like terms. Well, I mean, they already were before, right on this step right here, they're like terms. But, I mean, I had to clean it up a little bit first. So 2 minus 4 is negative 2. And that's the final answer for that one. Okay. I'm seeing a trend here. It seems like we can simplify each of these radicals, and then they become like terms. It's not guaranteed, but it seems like that's what's happening here. Always look for trends, and then kind of expect that trend to follow. That way, if you get stuck on something, it looks kind of weird. Just remember, like, oh, well, it's been like this every time, so it should be like this again, you know? Unless they change it up a little bit. But that's how it is with worksheets, is it's a lot of the same thing. So look for that trend, and let that guide you a little bit. 54 is 9 times 6. Square root of 9 is 3. Right, there was already a 3 out in front, right? So the 3 that I have right here comes from the 9, which does not include the 3 that's already out front. So be really careful with that. 3 times 3 is 9. If I put these guys together here, so that's 2 root 6 plus 9 root 6. Now they're like terms. 2 plus 9 is 11. All right. Moving on. This is the last two on this page, and then there's one more page, and then that's it, actually. 12 is 4 times 3. That's 2 root 3. It's a negative because there's a negative already there. Negative 2 plus 3 is 1, so it's just the square root of 3. All right, moving on. 27, 9 times 3. Root, square root of 9 is 3. All right. The other thing, too, is I don't have to do this every time. I know that the square root of 27 turns into 3 root 3 because I've taken the square root of 27 so many times that I actually know I can skip the middle step. So try to get to that point eventually. If you start doing enough of these, you'll start seeing the patterns and you'll be like, oh, 27, that's 3, 3, right? So then I have 3, 3 minus, oh, hey, hold on. That's the exact same thing. That's any number minus itself is 0. Even when there's radicals. It doesn't matter what the number is. It could be imaginary numbers. And if you've never heard of those, they are actual numbers. I was going to say they're real numbers, but they're not real numbers because the real numbers system is a whole separate system. There's actually a thing called imaginary numbers if you haven't heard of them yet. But they're still numbers. So if you subtract them and it's the same one, you get 0 still. So anyways, moving on. All right. I'm going to start speeding up a little bit. I already know that the square root of 8 simplifies to 2 root 2. And then I've got a 3 out in front still. That's going to be 6 root 2 plus 3 root 2. Oh, not plus. Equals. 6 plus 3 is 9. 9 root 2 is the answer. All right, this one is the same thing. It's a negative 3 root 6 and then a positive 3 root 6. They cancel each other out. Okay, 20. That is 4 times 5. So 2 root 5. Right there, right there. A little bit more space to finish out that problem. Negative 6 root 5 minus root 5. And when it's a minus root 5, remember that's a minus 1 root 5. Minus 1 root 5. So minus 6 minus 1. Add them up to get minus 7. And there's your answer. All right, 45. 9 times 5. 3, 5, 2, 2. 2 times 3 is 6. Root 5 minus 2 root 5 is 4 root 5. All right, time to ramp it up even more. Okay, this time, I'm not going to show the middle step for any of these square roots. Square root of 18 is, you could say 6 times 3, but remember, we're trying to figure out square factors. 9 times 2 is 18. So that's going to be 3 times 3 root 2, right? 9 times 2. So then the square root of 9 is 3. And if I'm going a little bit too fast, that's okay. You can go back and re-watch some of the earlier stuff. I go a little bit faster on each successive problem just to show you what it looks like as you start to get the hang of it. Right? So I do that with every worksheet. It's really helpful for you because then you can see, okay, this is what it's supposed to look like when I start to get the hang of this. That's where you want to get, right? That's why you're watching this. You're watching this because you want to know how to do it, right? So let me show you how to do it. I actually showed the middle step there and I didn't mean to. I was talking and writing at the same time. And sometimes I don't double task very well. I did simplify that one though. That one would be 2 root 6. So this one actually not everything's going to go together. This one's a little different because that's going to be negative 9. That's going to be square root of 9 is 3. I'm running out of space here, so I have to kind of consolidate here. Square root of 9 is 3. Times 3 is 9, so that's minus 9 root 2. Plus 6 root 2. Minus 2 root 6. Okay? Not all of these are like terms. This is the first time that's happened, right? This is a little bit of a curveball. Negative 9 plus 6 is negative 3 root 2 minus 2 root 6. And that's as far as I can go because square root of 2 and square root of 6 are different numbers under the square roots, so they're not like terms. Okay. That is 9 times 2. Square root of 9 is 3. 3 times 3 is 9. Root 2. Square root of 12. 4 times 3. Square root of 4 is 2. 2 times 3 is 6. 6 root 3. Square root of 27. 9 times 3. Square root of 9 is 3. 3 times 2 is 6. 6 root 3. Right? Now we can put these guys together. 9 root 2 plus 12 root 3. And there we go. All right. Same thing here. Actually, this one's a little bit easier because I don't have to simplify any of the radicals. Negative root 3. Negative 3 root 5 minus 1 root 5. So minus 4 root 5 minus root 6. And that's it. All right, next color. Yeller. So now we've got negative 3 root 2. Square root of 20. 4 times 5. 2 times 3 is 6. And then that's going to be 2 root 2. 2 times 3 is 6. So we can put together this one and this one. That's negative 9 root 2 plus 6 root 5. All right. Moving right along here. Let's see. So then we've got minus 6 root 3 minus, 2 root 2. And there we go for that one. Okay. Here we've got square root of 20, so that's 4 times 5. Square root of 4 is 2. 2 times 2 is 4. Root 5. 18 is 9 times 2. Square root of 9 is 3. 3 times 2 is 6. Root 2 minus 2 root 5. Minus 4 minus 2 is minus 6 root 5. The other one stays as it is. It does not have something to pair with. Okay. So actually, this is the first time this has happened that I've noticed, at least. Notice these two are like terms already. I don't have to simplify. They can be simplified, but I don't have to simplify those. They're already like terms. 2 plus 2 is 4. That would be 4 root 18 minus 2 root 12. If you didn't see it, it's fine. You could simplify the radicals first, but you can put them together as is because they're already like terms. Now, we do want to simplify, though. So 18, that's 9 times 2. Square root of 9 is 3. 3 times 4 is 12. Root 2. 12 is 4 times 3. Square root of 4 is 2. 2 times 2 is 4. Root 3. And then I'm done because they're not like terms. Okay. Now we're on the last 4 here. Let's switch to like a... we could go to the next one. That's fine. Square root of 45. All right. 9 times 5. 9 is... square root of 9 is 3. Oh, sorry. My computer went and did a thing. It was yelling at me to plug it in. Let's see. 9... 5, there we go. 9, 3. Okay, so minus 3 root 5. 2 root 5. 20 is 4 times 5. Root 4 is 2. Root 5 minus 2 root 6. Whew, okay. So actually these cancel. Those two are opposites. So then we just have minus 3 root 5 minus 2 root 6. And that's it. Moving on. Notice all 3 of these are 20s. So we can just put all those together right off the bat. 2 minus 1 is 1 plus 3 is 4. So that's 4 root 20. Minus, I was going to put plus, but it's a minus 2 root 45. 20 is 4 times 5. Square root of 4 is 2. Times 4 is 8. Then we have 45 is 9 times 5. 9 is 3 times 2 is 6, root 5. And then look at that. Those go together. 8 minus 6 is 2, root 5. Okay, last two. So we've got square root of 45. That's 9 times 5. Square root of 9 is 3. Times 3 is 9. Square root of 12. That's 4 times 3. Square root of 4 is 2. Times 2 is 4. That doesn't simplify. And then the 20. Right, so 4 times 5, square root of 4 is 2. 2 times 3 is 6. Okay, so these two right here are the only like terms. And negative 9, negative 6, that's negative 15. Root 5 plus 4 root 3 plus 3 root 6. So now we've got 3 things. Only 2 of them actually went together. And you might think like, oh, well, square root of 3, square root of 6, those are so close. 3 times 2 is 6. Can't we do something with that? And the answer is basically no. You could do something, but it would be kind of complicated and it would be less simplified, not more simplified. So basically no. It has to be the same root. Now, if the square root simplifies, then that's a different story. But square root of 3 and square root of 6 both do not simplify. They don't have any factors that are square numbers. So you have to stop there. Okay, 27, that's 3 root 3. 45 is 3 root 5 times by the 3. 20 is 2 root 5. 45 is 3 root 5. All right, lots of 5s. So the 3 root 3, that's going to stay the same. Minus 9 minus 2, that's minus 11. Minus 11 plus 6 is minus 5. And that is it. That wasn't so bad, right? It's all just going through the steps. Basically, the steps are this. You simplify the radicals, then you put together the like terms. Well, I would say you simplify the radical, then you simplify the expression, because sometimes you have to multiply the numbers that you pull out of the radicals, right? So simplify the radical, simplify the expression, add and subtract the like terms. That's pretty much it. That's what I've done every single time, more or less. You don't have to follow those steps, but if you do, you get the right answer, right? Assuming you did the math right. So simplify the radicals, simplify the expressions, put the like terms together. Those are your 3 steps, and that's what you want to do. So hey, if you want to see this worksheet with all of this stuff and every other algebra worksheet with all of the answers like this, I take these and I just save them as PDFs and I throw them into my website, myersmathematics.com. So go check that out. Link is in the description below. And then also just go check out my free guide. It's called The 5 Math Mistakes Everyone Makes and How to Avoid Them. It's a super helpful free guide. You just go there and tell me where to send it to, and it just drops into your email. All right? So if you haven't done that yet, go do that, and I'll see you in another video real soon.